Hello and welcome back. Finally, we're doing the second part of Chapter 7 on wireless technologies, and a week ago we got as far as wireless security, and what I want to do is finish up the chapter talking about land management, specifically wireless land management. So just to quickly recap, go back and double check slide 36 to make sure you're comfortable with all the material on wireless security. Just kind of test yourself with some of these questions. But I'm not going to go through each one of these right now. But moving forward, uh, with wireless land management, it's just as important, probably even more important, to have good management practices in place for how you're going to handle operations on a day-to-day basis, how you're going to support these access points over time. We're talking about dozens, if not hundreds, of access points across your network, not just one like you have at home, right? So this is a very different environment when you're talking about an enterprise. So the first step is figuring out where all these access points are going to go. And the book has a good list of rules of thumb. Okay, there are no rules, only rules of thumb when it comes to where to put your access points. You have to make sure there's good coverage with minimal interference, which you just get figure out through trial and error, basically. 30 meter to a 50 meter radius is a good thumb in the air way to start in terms of how far apart they need to be. Brick walls are going to add more interference, though, and signal loss. Not interference, but let's say attenuation, signal loss. And of course, in a multi-story building, you have to think in three dimensions. The signal is going up and down, not just all around you in a circle. It's actually a sphere. And moving on, step number 4, I think, is the most important one, doing the site survey. Exactly like you've done in your homework. This is why I had you do it. Yes, it's painful and it's time-consuming and tedious, but it is so important to do. Not just, especially when you're initially laying out your wireless network, but ongoing, you have to do a site survey every so often, just make sure things are working the way you need them to. You can then, after you've done the site survey, do a more precise placement of where your access points are. You can tweak the signal strength in commercial access points. Unlike home access points, you typically can't fiddle with the signal strength unless you overwrite your firmware with like a WRT, DDR firmware, with whatever it's called, where you can start tweaking the signal strength. But normally on a residential access point, you can't do this, but you can on a work access point. You're paying a couple $100 more to have that level of management. So this is what enables you to, if you don't want to blast signal out into your parking lot or across the street, you can dial back the signal on those edge access points that are at the edge of your building. So that's a good idea. Yeah, so the last thing you want to do is be running around trying to physically interact with every access point, plugging into every access point to manage them. You want to be able to manage them remotely, of course, and not just remotely from your desk in the office, but remotely away from the office as well. So this is the same management perspective that we had with managed switches versus unmanaged switches. Since I can't have you raise your hands for this question, but think about this: what management protocol you need your AP to understand so that you want to be notified of any equipment failures. There's a special protocol in the TCP/IP stack that we've talked about a couple times. At a minimum, this is lowest common denominator. What do you want it to run? Answer? That's right, SNMP. Very good. Okay, let's move on. Some other things that you want in a fully managed access point. You don't have to have things, but you have to have these things for the access point to work, but you need them in order to be able to better support it and provide better service to your customers, I think. So being able to notify you of any failure, whether it's by text or an email, or at least an SNMP trap that goes to your SNMP network management server. Be able to configure it remotely. It's continuously monitoring it for quality. Being able to push out software updates, not just one at a time, but to all of them at the same time. is a huge time saver. Now, as long as you kind of tested out the firmware, you know it works. After you do a trial run with 1, 2, 3, 4 access points, don't do them one at a time for all 50 access points. You want to have a management platform that allows you to push out that firmware update, boom, to all of them, so you're not spending hours on the weekend doing it. And if it can do it automagically, that's great. Some things that you want security-wise, you certainly want to be notified if anybody sticks their own access point, starts broadcasting in your area. You certainly want to be notified if you suspect an evil twin attack, where somebody's put up their own access point. Remember, go back and look at the slides of how an evil twin attack works. Somebody puts up their own access point, and it's passing traffic back and forth. But basically, you've got a new BSS ID on the network that you previously did not have. And so remember, the BSS ID is the same thing as a MAC address. If you've got a new device on the network, you want it to let you know so that you can be proactive about tracking it down. Certainly, if there's it's not any kind of attack, but especially a denial of service attack over wireless can be heinous. Yeah, that's the word. So, same thing with dissociate message. I don't even know what that means. I'll have to go back and look at that one. I would ignore that one now. Just focus on generic denial of service attack. And ideally, if it can deny access to any box that's being a troublemaker, it's one thing to do error detection. It's quite another to do error correction. So option A, it just lets you know something bad is happening, but option B is it lets you know something's bad is happening, but it also does something to stop it. So this is kind of the difference between, maybe late in the semester we'll touch on this, the difference between an intrusion detection system, an IDS, and an intrusion prevention system, an IPS. Excuse me, I need a cough button, since you don't have to hear that. So now what we're going to try to do is, you know what, just to be on the safe side, I'm going to set this up in part 2 of this video. We're going to try to rebroadcast these 2 videos within this presentation. We'll see how well this works. Maybe since I've got a few minutes left, I'm just going to skip ahead to talk about decibels, is how we measure signal level. What a great test question that is. You know this already, how you measure decibel strength or signal strength from your homework assignment in Xeris. And notice that all these numbers are negative, from negative 70 to negative 90 is kind of your range. And if you're wondering about why we're talking about negative numbers, it has to do with the mathematics of logarithmic scales. So if you're interested in this kind of thing, there's an explanation for you. But this is all you need to know in a nutshell here in terms of signal strength. So with that, before I go on to other wireless technologies, I'm going to queue up these YouTube videos. So I'll see you back here in just a minute.